All right, let's continue our discussion on data types. Why are data types important? Well, because every data type is stored differently in memory for the computer, and they're operated on differently. They function differently. They're different, and you need to know while you're programming what data type you're using because you will need to operate on them differently. For example, you can only do math on number data types, not on letters or words. You can't do math the same way you can with numbers. So you have to know what data type you have and be able to convert to and from and be able to know which one you have. The next one we're going to talk about is called the Boolean data type. It's named after George Boole, who was very instrumental in logical, some of the logical stuff in mathematics. But basically, a Boolean data type, it's probably one of the simplest data types. It's only, they can only hold one of two values, either true or false. That's it. So, a 1 and a 0, basically. You know that in computers, everything at the lowest level, is either a 1 or a 0, on or off. That's it. So Boolean is very useful for computers and programming, and we're going to kind of get into how to use the Boolean data type. So as I mentioned, it can only be true or false. There's no in between, no maybe, no potentially or possibly. It's just yes or no, on, off, true or false. That's it. So to declare and initialize a Boolean variable, it's the same way as any other variable. The only difference is here you're going to set it to either true or false. Notice the capital letter, capitalized true, right? It would also be a capitalized false. Okay. Lowercase does not work for Boolean, at least not in Python. So now all that means is that this variable, holds the value of true, Boolean true. Okay. And why is this useful? Well, as I mentioned, everything is either a 1 or a 0 in computers, so they're very, very helpful, and this is how you'll make decisions in your program. Okay, while you're coding, you're going to say, well, I want this to happen, but only if something else is true, right? I only want to do this if something else is false, or whatever. And that's the control structures, which we'll get into in another video, but the control structures are what make programming possible. So here's an example, right? You can compare values. So here I've got my integer and I set it to a value of 84, and then I create another variable and I'm going to say, okay, let's just set my variable equal to my integer greater than 100. Well, this is it's a question basically. Is my integer greater than 100? Well, Python's going to look in here and say, all right, give me the value here at 84. So 84 is not greater than 100, so let's set this value to false. Okay, and that's it. So now this variable contains the value false, and you'll see what I mean here when I print this. Python's going to print false because my integer is not greater than 100. It is less than 100, so it prints false there. Okay, you can also compare strings. We talked about the string data type in a previous video, but here, for instance, I set my string equal to the string literal of good, and then what I'm doing is I'm creating a variable called isGood and setting that equal to is my string exactly equal to good, and another string literal here, and that's going to say, well, it's going to get this value and compare it to this value, and if those are the exact same, it's going to set this to true. So let's see what happens. All right, there we have it. So I also want to point out here, you'll notice that I have two equal signs here. That is not a typo, okay? In Python, a single equal sign is the assignment operator. So I've got my string, I'm setting that equal to good, right? Assign good into my string. The two equal signs is the comparison. I'm comparing two strings. I say, okay, my string is exactly equal to this, or does my string equal the value of good, right? It's I know it's a little tricky, especially for newer programmers, but and I mean even more seasoned and experienced programmers make the mistake of using only one instead of two equal signs when they're trying to compare, and it happens. But just try to keep that in mind. If you're ever comparing two values and you want to make sure, you want to check and see if they are the same, then you'll need to use two equal signs. Okay, here's a quick rundown of the Boolean operators. You've got your exactly equal to, which I just mentioned, not equal to, which uses the exclamation point and then a single equal sign. That just will return if they are not the same thing. Okay. Less than or equal to, greater than, and greater than or equal to. I hope those kind of make sense. They're pretty straightforward. Another thing I just kind of want to mention here real quick while we're on the topic of some Boolean stuff is naming conventions for Boolean variables. As you can see up here, I kind of used those naming conventions. You want it to kind of be a small question that you can answer with either yes or no. You don't want to have it be something like favorite car, right? That's not a yes or no question. If you were to walk up to somebody, hey, what's your favorite car? And they said yes, you'd look at them like they're crazy. But you could ask them, you know, is that a car? And they'll say yes or no. Well, that's a yes or no question. It can be, so that could be handled with a Boolean variable. Is car, for instance, right? So you just kind of want to make it a little question, right? Here's a few examples. Is available, is open, can edit, has value, right? They're questions that can be answered with yes or no. A true or false question, if you will. And that's kind of the essence of what a Boolean variable, what a Boolean data type is. And they're extremely helpful for control structures. And like I said, here we'll talk about the control structure just kind of basically here, and give you the rundown on how they're used, how you can use Booleans with this. So, like I said, you can make, computers and programs, and they're so powerful because you make decisions inside the code. You execute differently based on certain conditions. And in this case, you use Boolean values to determine which code to execute. Okay, so in this case, remember earlier I set up a value called, or a variable called is greater than 100, and I set that equal to is my integer greater than 100. Since my integer was less than 100, it set that value to false. So now what I'm doing is I'm checking the value, I'm checking this condition. And it's just a simple, very fluid, should be a very, very fluid comparison to normal speaking, right? If something is true, then do something. If then, right? If you're hungry, get some food. If you're thirsty, take a bite or take a drink. So it's the same kind of thing here. If is greater than 100, right? You could do something like this, and you could compare if is greater than 100 is equal to true, right? But that's kind of redundant. You don't need to put this here if you're checking to see if it's true. Now, if you were checking to see if it's false, you would have to do something like that. Okay, but if you just want to check and see if it's true, since this holds a true or false value, you can just do something like this, right? If is greater than 100, and then that's going to evaluate to either true or false. If it's true, right, then this code will execute. But only if this is true. If it's not true, then it's going to skip this line entirely and come down here to this else statement, right? And an else is another function of normal English language, right? If you don't clean your room, clean your room or else you're going to get in trouble, right? So it's the same kind of thing. If you do this, then do this. Otherwise, or else, you need to do this. Same kind of thing, right? If it's greater than 100, then do this. Else, print this, right? So hopefully that makes sense. It's obviously it's logic. It's very logical here. That's what Boolean is all about. Now you can also use multiple conditions all at the same time, right? And these are some more Boolean. These are called Boolean operators. or logical operators even. You can use the and the or keyword, right? Boolean and Boolean or. So, and again, it kind of works to some of your normal language. Might be a little different than how you would interpret it if somebody was speaking to you in English, but here's kind of how it works with Boolean logic. Okay, if is greater than and is good. Okay, so this statement right here can only run, can only execute if this entire condition is true. Okay, so with the and operator in here, then this has to be true and this has to be true, and then then the whole thing is true, and then this will execute. Okay, if this one's false or this one is false, then none of this is true. The whole thing is considered false, and then it skips this line and goes down here to this else. Okay, so here's another example using the or operator. What happened? I did not want to do that. Okay, so here's one using the or operator. So what it's doing is it's going to check this condition. If that's true or if that's false, then it's going to check this condition and say, all right, is this one true? And if either one is true, then the whole thing is true. Okay, this one could be false and this one could be true, and then it says, all right, well, now I'll go ahead and execute this. But if this one's false and this one's false, then the whole thing is false, and it comes down here to this else part. Okay, so hopefully that kind of makes sense. I'm going to give you a quick, I don't know, table visual. Maybe you can visualize this a little more easily. So this one's for the and condition. Okay, so you've got one condition over here, the true and false, and then you have another condition here and the true and false, and you're comparing them using an and. You're adding them or checking both using an and condition, the and operator. So if this one is true and this one is true, then the whole value is true. Okay. If this one is true and this one is false, then the whole value is false. Okay. And moving on, if this one is false and this one is true, then the whole thing is false. If this one is false and this one is false, then the whole thing is false. So as you can see, in order for any of this to be true, they both have to be true. Okay, both conditions. And I mean, you could even have multiple. You could have 12 conditions all in there, and if they were all strung together with an and, then each and every single one of those would have to be true in order for the entire condition to be true. They're all just little pieces to the full condition. If any of those pieces is false, then the whole condition is invalidated as false. Okay. There's with Boolean, there's really no gray area. It's black and white, true or false, yes or no. Right. So here's another table for the or condition. Okay, so if true or true, then it's true, right? If true or false, then the whole thing is true. If false or true, then true. So basically, that one is always true unless they're both false, right? As long as one of them is true, the whole condition is true. So that's the or operator. There is also an exclusive or, which would check to make sure only one of them was true, but that's a little more advanced. We're not going to get into that in too much detail here. Okay, so the Booleans are good for like the if statements, the control flow, as I mentioned a little bit earlier. They're also good for loop control, right? You can control your loop, and that's how they work. So here I create a variable called can_continue, and I set it equal to the value of true. So while can_continue is true, and I could have done something like this, right? But again, that's a little redundant because I'm checking to see if true is equal to true, and that's just kind of redundant. But you can use just a variable name here if it is a Boolean data type. If I had a let's say a string data type, right? Other var equals, I don't know, go, right? then I could do something like this. If other var is equal to go, right? Then you would need something like this. So this will just compare, and this does, since it's a Boolean comparison operator here, the double equal sign, it would return either true or false, right? If I change this to stop, right? Well, now other var does not equal go, so that's going to return false. Oops, I'll leave that there. Okay, so moving on. Basically what this does then is a while loop will execute as long as this condition is true. As soon as this condition becomes false, the loop is done. So here what this will do, I've set can continue equal to true, and then it's going to start this little while loop. Alright, while this value is true, then I can do this stuff in here. So it's going to print I'm looping, and then what it does is it sets can continue to false, and then it jumps up here. It says, alright, while this value is true, oh, it's false now, so it's going to jump out of the loop and continue execution beyond if there are any lines. Okay. The next thing I want to mention is you can flip the value, toggle the value of a Boolean variable using the word not in front of it. Okay. So in this case, I'm going to create a variable called my Boolean true. I'm going to set it equal to true. Okay. Now what I want to do is I want to print not my Boolean true. So what that's going to do is it's going to take whatever value this is, either true or false. With the not keyword there, it's just going to flip it. So if it's true, it's going to be false, and if it's false, it's going to be true. Right? It's kind of might be a little confusing to think about, but it makes a lot of sense when you really think about it. So here I'll show you what's happening. So I'm setting my Boolean equal to true, my Boolean true equal to true, and then I'm going to print the opposite of it. Okay, so you'll notice it prints false. And that's just because false is not true. My Boolean false equals false, so I'm going to print not my Boolean false. So it's going to print true because true is not false. I hope that makes sense. Alright, and really the last thing I want to mention here on the Boolean type is that you can represent a Boolean using numbers. So I mentioned earlier ones and zeros. If it's a 0, it's false. If it's not a 0, then it's true. Okay, it doesn't just have to be a 1. I could have done 17 and my Boolean integer. Right now, when I check it, Python's going to say, all right, if my Boolean integer is not equal to 0, if this is considered a true value, anything other than 0, then it will execute this inside here. Okay, but if this was exactly 0, then that would not be true. It would say, oh no, this is considered as a false Boolean value because it's equal to 0, and then it'll print the else statement there. Okay, so that's kind of the rundown on Boolean data types. They're very useful. They're very simple, simplistic. There's not a lot to them. It's either true or false. I mean, that's it. You can combine them using the ands and the ors. Just be careful when you're doing that. You got to consider things. Make sure you don't make it too complicated. You can flip the value of it using the not keyword, and yeah, they're used primarily. They're used. What the whole purpose of using Boolean data types is for control flow. Okay, do you want to execute certain code on a certain condition, or do you want to execute this code based on a different condition? While you want to do a loop condition, right? You will run over a whole bunch of code over and over and over again until something is false. That's the whole essence of what Boolean is, why we have it in computer programming, and how to use it. So hopefully that makes sense, and we'll see you next time.